Hey Surya, how are you? Hey, hey. So, um, what are we here for? Um, what we have discussed is that we're gonna do a few sessions for building a real system in Java. That real system is a system that probably most of all the engineers I know have interacted with at some point. You and me, Zuriel, we've done a lot of databases back in the day, and this is what we're going to try to build. Obviously, uh, a database system is a really complex system. It is really well optimized, and it's scalable. There's a lot of things that it does. We're not going to do many of these things. Our plan is not to build something that is robust and production ready, but it's more to build something simple yet representative of that, so that we can learn, we can see how to build a complex system, and we will probably make a lot of shortcuts to accommodate this, to be able to focus on building rather than making it really bulletproof. Um, so what does a database system has? A database system is, you can think about it as a server. We will not do a server. You're not going to communicate with it over HTTP or anything. It's going to be a local server that you can send commands. You can issue some commands to create tables, to manipulate data inside tables. You can insert rows into a table. You can delete. You can query. You can do all these things, which we will do. Um, Ours is going to be a simple one. We're going to start, I think, by breaking this problem into smaller pieces and postponing as much as we can so that we don't have to build everything up front before we can see anything. So for example, what we will do today is going to be us holding some tables in memory. They're not going to be saved to a disk. They're not going to be saved to a file. So if you restart the we're going to use Java. If you restart the virtual machine, the Java virtual machine, you effectively lose the data. But that's going to be good enough for now, and we can do a follow-up session on just how do we actually write this into a file so that we can, not lose the data. So similarly, we will peel off a few other complicated issues that we might go afterwards and actually deal with. Um, Probably the system that we will have is not going to be performant. We might do a session or two on performance. It might not be concurrent, meaning if you modify it uh, concurrently by two different users, it might blow up. It might work, I don't know, but we will build it so that if you are issuing commands from one user, it's going to work. Um, so hopefully by the end of today, what we will do is we will have some way for us to insert data, any type of data, any specific data that we want into a table. Now let's see how we go there. It's not going to be simple. Um, Hopefully we'll get it as simple as we can. So where do we start? Do you have anything to add? Great. Okay. So let's start here. We're gonna build a new project, and this is gonna be a Java, and it's gonna be Java 9, and it's gonna be command line. That sounds reasonable. It doesn't have anything. It's just a simple Java application, a class with a main method. So let's see it. We'll call it database, and I'm gonna put it somewhere else. And we're gonna call it DB. Okay. You see my screen? Okay. So let's look at the project that we have. We have one file called main. There's a main method. There's nothing in it. And we can just write whatever we want. So what we would do, and this is important, in all of these sessions, we are going to mostly focus on writing maintainable code, meaning code that is easy to read, easy to understand, easy to reason. Why? I think there's two reasons. One is this is us trying to learn, and it's going to be really hard to learn if everything is going to be really complex. So a real database system might do a lot of low-level optimizations and optimize the code even to be performant. We will not care about any of these. We will only make sure that it's simple to read. And the second reason is, I think us as engineers, one of our main tasks is actually writing maintainable code in life. So even if this was not a database system, but an actual system that we have to build for our company, I think this should be our main goal as well. Okay, so where do we start? I think we can do two ways. One, you can model the different objects or classes that you have, and this is how normally you start. You say, hey, I want to have a table, I want to have a row, I want to have columns, I want to have cells, these sort of things. Or you can start from, which meaning like a bottom up. You build individual objects and then you connect them somehow. Or I think you can actually start top bottom here, and it would actually make more sense. So top bottom here would be, let's write how we want our code at the end of the day to look like. Sometimes people call this TDD, where you write the test first. And this is going to be our test. It's going to be here on the main. So let's start here, and then we'll see. So by the way, I'm using IntelliJ as my IDE. I'm using Java, and I'm using a Vim plugin. So if you see me moving, deleting things in a different way than you would expect, it's because I'm using Vim shortcuts. And I'm going to use a lot of shortcuts, and I'll introduce some of them. I might put pop-ups explaining, hey, I just pressed Command Shift O for later. Okay, so how do we start this? So let's say there's a database class. Okay, let's say we call it database. Okay, there's no class like this. If I go here, it says cannot resolve symbol. There's no database. But let's say there will be. Now, let's say this is going to be one database. If this is a class, you can have multiple instances of this. We don't want necessarily multiple instances of the same database, but for now, let's say that is fine. So we would want basically to create a new database. So actually now with this, you can actually have multiple databases running simultaneously. But let's say we have a database, and then we can invoke stuff. So so what I'm going to do now is I'm going to Option Enter, which opens this, like trying to solve this problem, cannot resolve database. And now I can put a new class called database in the same package here. You see? It wrote this. Now I go back. Now this works, this one line. And now I want to do something with this. So let's say I want to insert into this table. No, let's say I want to create a table. Okay? So I'm going to do new table. So this is a method. This is one of the few top-level things you can do on a database. And new table, let's say we give it a name. Okay? We give it, what do we want? Do you want to do like orders? Like we're going to model some order system or something else? Do you have something nicer? Users. Okay, fine. We'll pick one. Let's do users, and then we'll put my name and your name, and that will be good enough. So let's say this is the table name, and we would want to put columns. For now, we're going to make it simple. There's no types. Everything is a string, let's say. And we're just going to put the different columns that are available. So here we can use a list of string. So these are the column names, and this would be new list, new. Yes. For, later, we will actually, on a follow-up session, we will switch from having code to interact with the database into using some syntax, some language like CQL. For now, we would actually do this, and later we will have something that translates whatever we type into these commands. Okay, so let's say this is I'm gonna use I'm gonna put it here, list of string. I'm gonna call it users columns, and this is gonna be new array list, and then I'm gonna do users columns dot add. So this is gonna be first name and last name, and one more thing, age. Now age would be a number on a regular database. Unfortunately for now, we do not support numbers. It's just gonna be a string. So we're gonna pass this. So this line will create a new table, okay, with 3 columns, no data, and this table is gonna be named users. Let's create this. Look at this. It doesn't know, there's no method table with these parameters, but I can create these. Poof. Okay. Now, we will implement this in a minute, but let's write the other ones. So we can somehow, we can, like this, we can actually build all of the interface that our database will have before we go and implement it. Okay. So let's say we created a new table. Should this return us a table object? I don't think so. I think we will treat this database system like a SQL server. On SQL server, you run another command. This is a new command. It could be a new table. It could be give me data from this table. So you don't work against a table. You always work against a database. But we would want to store this database because otherwise we're going to lose the data eventually. So after this line, if I do this, for example, this will work because there's not going to be any tables on this new database. Yeah, so we're going to share the same database throughout this code. So let's do I'm going to move this into a, you see there's some magic going on, like I press a button and now there's a it took the new database and put it here and variable and reference the same variable. So if I try to do this, I expect this to actually fail. Yeah, this should fail. Yeah, does it make sense? Because there's already a table. Let's leave it like this, and we'll see how we change this code so to show that it fails or not. But now let's say we want to do something. We want to insert into the table. Okay, so I'm using the same names that CQL would have. So what do we want to insert? Let's say we want to insert into users, and we need to give it, let's keep it kind of similar. So let's say this is going to be user1, and it's going to have you. Do you want your full name or no? Okay, this is your name. You want your real age or no? It's mine plus 10, so it's 47. Did I get it right? Okay. Okay. And then I'm gonna do another one, user 2. And this is gonna be Ohad, Kravchik, and this is 37. You see how I changed, like, this is nice that in Vim you can say like poof, delete this word and replace it with something else. So let's say now we would call this, so into users, and you give it a list of the values that you want to insert. So this would be user 1. We can rename this to be Suriel, even though it doesn't do anything. Yeah? Suriel. And this one would be user 2, and we can rename it to be Ohan. Okay, now we can create this method. Okay, we will change this in a second. So we inserted 2 users. Let's say we will do a simple query. So we'll call it select, like the query command. And right now there's nothing that you provide. You just say give me everything. Okay, this is simple. We wanna simplify what we have. So this thing runs, but this time it actually gives us back some results. So we would want this to return something. So we will call this, so in CQL, you would get a record set, yeah? For us, we would not gonna use the features that a record set will give us. Instead, what we will do is that this returns a list of something. Yeah, it's not that easy because we need to give it a specific thing. So let's say it's a list of row, okay? So what is a row? I don't know. We don't have that yet. But we can think of that a table consists of list of, some rows. Okay? We don't have that yet. We will have it soon. So let's introduce this select. Okay? This returns a list of row. Okay? And let's create row. And row will have basically 3 columns. So if you want to, let's do this. Let's print whoever's in the table. Okay? Yeah? So let's do 4. I think it's iter for each row. And what will we do? So, let's say this is, let's print something. Let's do users. Oops. Users. So we are going to print users, and for each one, we're going to print the 3 fields that we have. So row will have get value, and we give it first name. Yeah, is that how we want to build it, or some other? Should we build it as like the first column? How does it work in CQL? You say get select. No, but yes, but when you get everything back, you reference them by field names. Yes. So let's try to be consistent with it. So it's gonna be like this, yeah. So let's do a get value, and this would be the column name. Okay. Okay, and we're gonna print this. So this is gonna be user. This is gonna be user. Let's do string.format, and this is gonna be user first name last name. age, the age. Yeah? And this is going to be first name, row, get. Let's implement one of these. Row, yeah, and you get this. And then get value last name. And then row dot get value age. Almost. Yes. Yes. To actually implement this, we will build a few more things that we will want to have. That right now you do not interact with them, but we will have them. So here's our simple database. Yeah. Okay, and hopefully something like this will fail. So let me write row value does not exist. Yeah, should fail. Same as the one above. I don't know, the auto formatter did whatever it wants. But okay. Okay. Is this fine? Does it look fine? Sure. Adding users, selecting and printing all users, and let's change this to be this, and then creating table. Yeah. Yes. Okay, and then we will have to disable the ones that should fail. Oops. We will have to disable these lines because these are going to explode, but let's have them explode first. Okay, so let's deal with the first one because this is going to be where we will have to build most of the infrastructure. So you call new table. You give it a table name and column names. Column names. So we need to keep a list of tables. Yeah. So let's create this, a list of table. Now the reason we would want to create a new entity such as table is because table actually has things that we have to store, like what columns it has. If you remember, we need to know that these lines would work, but this one would not. So we need to know what the columns that we have. We'll need to store it. So we will actually implement this table. And we don't have anything with it yet, but list of tables. So this is going to be, we want this to be empty. Yes, tables are here. No, we don't have one database. We have one database in this example. You can actually create a new database here or anywhere. You can say, you can actually create another one. Database 2. Yes, it's going to have its own tables, yes. So basically this instance of database is going to have tables. Later we will persist this and we will remember what tables we have. For now, they're going to start from scratch every time. So here, this is a new array. This is an empty array. So when you start the database, when you create a new database object, you get no tables. Okay? So we're gonna do something. We're gonna move all the code related to what is a table, not to have it here, but have it in the table object. So we're gonna do tables.add new table, and we're gonna pass everything to it. So we're basically delegating to table to have a constructor that uses this data and do something. So this object, what it does is it's just the facade of everything that you can do against the database. Yeah, all the methods that you can interact with are coming directly from here. Okay, so here we can say create this constructor. Okay, what do we do with this? I would say let's just store these. I don't know if there's anything more interesting that we need to do. For now, this kind of looks fine. Yeah. Yes, we don't have. Yeah, we have row. It's empty. So let's. One thing that we might want to do is when we work with array list, people like this list, people can actually modify this afterwards. So the list that we get, if we include it here, this opens up the possibility for somebody to actually come afterwards and say this, and this would actually modify the table. This is not what we want. So what we will do is just we will build a copy of the thing. So we will do, I think there's arrays, sorry, not arrays, lists dot, is there something like lists, collection list of, is this what I want? Return an immutable list containing 0 elements. Okay, yeah, that looks fine. So, oh, wait. List of, yeah, no, not resolve. List. Didn't have, oh, this is an array. Okay, this is why. This is an array. So we're gonna just do the old-fashioned way. New array list. Okay, so now this array is different than the one that you pass, and that's fine. There's not gonna be this weird case. What else? So we know the table name and the column names. So for now, what you will see is, if you think about it, if you want to insert data into a table, yeah, this is the table name, and this is the values. Yeah, if you want to insert, let's say we want to implement this method. How do you know if this table exists? Yeah, you need to go find this table. Yeah. How would you find this table? You don't have the names here. You have to go under each one and see what its name is. Yeah. Which is, so in a real database, what you would do is you will build some mapping from name to a real table. For us, we don't care about that. We could do something to that, like actually just change this to from a list to a map of the name, but now we're making things a bit slightly complicated. Let's keep it as simple with list, and then we can modify that later. Maybe we'll have a session how we make this code a bit more, I wouldn't say performant, but more maybe simpler. Once we'll have some code, we'll see some things will be simpler actually if we use some data structure like a map. So for now, I want to know if this table exists. Yeah. So let's write check find the table, fail otherwise. Okay. So how do I do it? I will loop over I'll loop over the tables, and I will do if table dot now look at this. I want to get the name, and table has a name, but it's private. Okay, so I'm going to create a getter for table name. For now, I'm exposing table name. Okay, so I can say get table name equals this table name. Yeah, this is the table I want. Found the table. Yeah. Now, I see how I want to do this again and again. So I'm going to need to do this here as well. String, this is table name, sorry. So I'll need to do this again here. Also, I don't want this insert method to be like 200 lines long. So this is what I'm trying to do, is to find a table. So let's move this into a method. Call it locate table. Okay, so I just call this thing, but now I want to return. So I'm gonna return an optional of table. Optional has two options. Either it's empty or it has a table. Okay, so if I found a table, I'm gonna return optional of table. Okay, if I haven't, I'm gonna return optional dot empty. Okay, so now why is this is never used? Okay, so now I can say something. Okay, and now this is important. Sorry, um, if we insert and the table doesn't exist, what do we do with it? If you wanted to insert into a table, the table doesn't exist, what do we do? Yes, you get an error. Okay, so we will decide for now that we're gonna throw some runtime exceptions. So if table dot, if there's no table, we're gonna throw new, and we're gonna do, so in Java there are checked exceptions, which something like IO exception, that you see it complains that you're throwing something, but you have to declare this. So you have to declare. Now this is ugly because it means that people have to worry about this all the time. But this is not something that people should worry about in databases so much. Like, they can assume what they're doing is fine, and once in a while you explode. So instead of throwing IO exception, which is a checked exception, we're gonna do a runtime exception. So runtime exception, there are a few particular ones. So let's see what we have. Runtime exception new, just to show what are the options. You see, these are the runtime exceptions. So I can just put a generic runtime exception, or I can put something more specific like illegal argument. Okay, you gave me an argument called table name, it's illegal. So let's do this. New illegal argument exception, and you can give it a message, and let's put something meaningful. Table and table name doesn't exist. Okay, string dot format table. Okay, yes, correct. So let's do this. we go first to locate this table, and if it exists, we will fail saying cannot create table X as it already exists. Okay? Yofi. Great. So now we have the table. Actually, if you want, maybe after the insert, we start running this code. And we will see that it fails. We can actually add some of these checks. So table doesn't exist. If sorry, it doesn't exist. Yeah, do you want to add? You want to add test? No. So database is fine. The two databases are fine to coexist. Nothing here. There's no name. Databases doesn't have a name yet. It's just a new. Yes. When you say new database, you get a new database, and that's it. Okay. So actually, maybe we start now testing this part, new table. So we wrote some code. If it exists, doesn't exist, let's try it. Yeah. So we can say new table users, and this line should work, and this line should fail. Let's try it. I'm gonna do run. It's building, parsing Java. Fail, exception, cannot create table users as it already exists. Where? In this line. Look at this, in this one, not on this one, on this one. And if I had another table, and we call it customers, that thing would have succeeded as well. So again, I'm running this again because we start the JVM from scratch, and we have a new database. The database is empty, so we can run it again and again. So it failed, and again it failed on this line. So our code actually worked. Okay, so what we can do, this is how you write test is, so what do you do with this now? Like, we're never going to be able to run the rest of the code, yeah? Because it's failing. It's going to fail here. It's not going to go to the next line. So one, you can disable this, yeah? But actually what you would do in a test is you would say, I want to see that it fails. So you would do this. E. And you would say, you would call it ignored or expected. And you would not do anything here, but you will fail here. So you will do a fail. Let's put a fail, just so that throw new runtime exception failed. Yeah, okay. So just so that it's simpler. So if it finished this line without failing, it will actually gonna fail. But then will it catch it or no? It's a good question. It might actually not work because it might catch this thing. Let me see. Okay, you know what? Let's. We are digressing to a different topic. So let's undo this. And let's do this. Yeah. So I'm just disabling this line. And if we try to run insert, it should work. It doesn't do what it needs to do. Yeah, and you see it starts failing somewhere here. Okay, so it did do even these lines, but it didn't actually store the data. We know, we didn't write anything. No, there's no error. So I disabled this line. Okay, so it actually succeeded doing insert, even though we don't store the data. And it failed here. So let's go to implement the insert. So insert, what would we do? We found a table, okay? Now, this is really useful because we can just do something on it. We can say insert, so we have an insert on the table, and we just pass it the values. So here, we use this param to find the table. We found the table, we call insert when we give it the values. Okay, so why is it not letting me create? Oh, okay, because we need to do table.get. Table.get. So this is how we get the value. So this is the optional, and it has method like isPresent, and when you want the value, you call get. And now we would want to insert onto table. Okay, so insert list of string values. Okay, so we will, what would we want? This is one row, this thing, yeah. It's weird because we already have a row object. So this is a row that you retrieve. If you would say get value, maybe we'll use this to also set values, because it's weird that we accept a list of string but we return a row. So maybe we change. Yes, let's switch to rows. We made a mistake here, and we will do row. Okay, and now it's a question: how do we set a new row for insertion? You see, because we had this list of users, list of, yeah. So we will do new row, and this will be a, instead of a list, this will be like this, yeah. Change variable to real to be row, and oops, oh, we had a mistake, a big mistake before. You see, we added it to the columns to real, and this one was ohad. Okay, so to real, we want to, now I don't think it should be named add, because we had get value. So let's say set um, set value. For now, we'll do the same thing, and you give it the name of the column. This is how SQL works, yeah? Because you say insert, and you give it like pairs. So the SQL command is insert into users, and you give it the names of the columns. So this would be first name, last name, age, and you do this. So the Turiel, Yahav, and 47. So this is the equivalent in SQL. So you give it basically pairs of column and value. So we will do the same. So we will do set value, and we will give it first name Turiel, and then last name Yahav, age. Okay, and this is going to be all. Oops, sorry. Okay, so row is empty, and we can set stuff on it. Yeah, so row. What is a row? A row is a list of values. So we would want to store a bunch of these. Yeah. So this will be first name is this, last name is this. This usually goes into a map. We can do two lists if we wanted to, but it's usually a map. So we can, I don't know which one is easier for you, but as a Java engineer, map is actually easier. You can have list of string columns and um, list of string values, yeah, and they should have one item in each of these, yeah, but it's hard to manage because you have to work with indices. So instead, you can say map from string to a string, and this is a column to values. And here, so you will, we might change it in a second, but new hash map. What you will do here is you will do, and this is not last name inside Yahav, this is column name, and this is value. So you will do column to values, put column name and value. Yeah. So this is a map. It for it for any value, any of this string that you put, which is the column, you can have at most one value. Okay, which maps exactly to how CQL works. You cannot have two columns of the same name. Okay, so what we could do soon, and maybe we do it sooner than later, is actually have a column as an object. For instance, and this is also a good reason why we have classes here, and why we don't do it all on one table object, is because later, as we make more complications into the system, it's good that we have somewhere to capture it. So, for example, a column right now is a string, the value is a string, but we know the value we will need to change later to include numbers. So then we'll have to go and change a lot of code. Yeah. So yes. So this instead of being a string will be a cell. Yeah. You wanna do it now? Let's get it, maybe this one running, example running, and then we will. Okay. So now you set a new row. You put the values on it, and then you call insert. So let's see what we do with this row. We call insert with the row, and we got a row here. Insert into the table. So the table doesn't have data. Yeah, did we columns to values? Sorry, this is in a row. It has different columns and values for each one. Okay, so this is one row. One row is fine. Now, so basically, what we need is a list of rows. Yeah. So we will do list of rows, private, final, new. Okay. And then this thing, rows dot add row. Yeah. So you get a row, and you put it into this. Now list. There's some question here related to Java, because row might be duplicate. You can actually have the same columns and values. So you have to ask the question: is it allowed in CQL or not? We both know that the answer is depends on the table, because in CQL you can actually do a primary key, and then you cannot have duplicates, but you can actually skip primary key and you can have duplicates. So for now we're not going to worry about it, and this code that we have allows duplicates, because we never said, um, you know, yeah. Yes. So actually a list allows duplicates. If we were changing it to set, we would actually start losing duplicates. But if we go to list, somewhere here it says, maybe somewhere at the top, allow duplicate elements. Okay? So you can have two of the same list, same row. Okay, so we have rows. Content of rows are updated whenever queried. That's fine. You add a row, and then inside, when you add the row already has parameters. But that's okay. So we're not doing everything good yet because the row is being created by externally, like here. Yeah. So I can do this. It should explode. Yeah. Okay. We will, as we will change this soon to have columns objects. We will make avoiding this situation easier. But let's do this. Let's run this before and then we'll see. Uh, okay, so we have two rows, and this should work because it actually um, at, so new row is an empty. Yeah. What we would do here is we would create. Um, we want to store for Tzuriel Yahav into the table. We said we're going to use row, so we have to give the table a row with the values that we want. Okay, so we pass here a row with the data field. Okay, and right now it's actually simple because all we're doing is storing this row in the end. Okay, so row. Okay, you could here use the same one. You could say this is user, user. Yes, so okay, if you want, we can change this to be user. And then instead of doing ohad, we can use user again. Okay, we will have a problem now that we will not have later because now we are actually storing this object. We are taking the row that you pass and we store it as is. So as you go later and modify it here, it would actually modify the one that we stored. Okay, we need to fix it. Yeah, we shouldn't rely on what the user gives us as our data. The same as we did for columns. When you create a new table, we copy the columns. Here, we copy the columns so that you cannot make changes to the table from outside. Only on this one line that you invoke, we create the table from. So we need to do the same for this thing. We didn't yet. But we will have two rows. So let's try to run this. And now we'll do something else. We will put a debugger. Okay? So I'm going to debug. It's going to run and it's going to stop on this line. Okay? But I can actually go into database. So I can see inside database there's tables. There's a list of one. The first one is users. Okay? It has 3 column names and it has 2 rows. Row 1, this thing, and row 2 is this thing. Now, if we, I'll show you what's going to happen. And you see, this is Toriel and this is Ohad. Yeah? Now, you wouldn't expect this, but if we were to use what you suggested, we will actually see something different. User. Okay? So this is what you wanted. Yeah? Okay. Now, we'll run it again and you'll see something really weird. I hope you'll see something really weird. You see this here. This should tell you what went wrong. You see this? This is the same row object. You see Ohad twice? Why? Because we are taking the row that you gave us and we're storing that thing. Okay? So when you change it afterwards and you insert it again, we insert the same one twice. Okay? So let's leave it like this and fix it. So how do we fix it? I think actually it would be a good time to switch to the column, and this will actually help us solve this. Actually, maybe let's solve it first and then switch. So we get a row object. We have a list of rows. Okay. What we would want is just this list of rows to not have any relation to the parameters that you pass. Yeah. So it's almost like there's two different rows. There's a row that we have inside the table, and there's a row that you can have for your use cases to send data to the table. Yeah. So for now, what we will do is we will basically clone. What we want is a new row of the same thing. Yeah. So every time you give us a row, we copy it and we store that copy. For now. So let's do this. We have a row. Before we edit, we're gonna clone it. We're gonna call row.clone. Um, yeah, okay, there's already a clone. Let's call it duplicate. So this one returns row. So we can do new row, row, do, and then we will do this ugly thing, which we're gonna do column to names, new hash map, and we're gonna give it this thing. Oops. I don't know what's going on with my ID. So it's not ideal, and hopefully we can change it soon. But it copies the data. So now this should work. Let's try this just to see if we have one or two rows. Basically, if we have the same row or we have different rows. Okay, so you see the row that we have here, which is user, is 650. But we added 658 and 659. Why? Because every time we copy it, we don't even use the original one. We copy it. Okay, so we created two new ones and we stored these ones. Okay, so this is good. We can go and implement this part, but we still are not done actually. Our insert is not really correct because you can have anything you want here and it's just gonna work. Okay, so I think in order to fix this part, a good way would be to actually use the column object, because then the same that we did with table and we have an optional, we can use the same for columns. Okay, so let's introduce column, a new object called column, and maybe a new object called cell. So table. Um, Too long. Okay, so okay, it's fine. I'm fine with that. But what we should remember is this is not just a simplified example, it's an incorrect one because nothing prohibits you from doing this. It actually will not explode as it should. It's not gonna err. So let's the way to do this, if we want to do and continue without fixing this, is to put a to do here so that we don't forget. So to do, we have to verify that columns match the table definition. Okay, so it's fine not to do it, except if you make a typo, you wouldn't know about it. Okay, so but that's fine. Let's do this part. It should be relatively easy. I want a list of row, so I want the same thing as before. I want to get the table. If there's no table, I want to explode. And then if I have the table, I can do get and then get um, rows, because this thing here, if we go inside table, it already has a list of rows. So if we create a getter, that's just gonna work. So this is a list, and again we have the same problem. We shouldn't share lists, because when we share a list, it means that somebody from the result could actually modify. So we're gonna do the same. Okay, so we return this thing. So this gives you a rows. I think this will make our example work, except we didn't do get value. Yeah, we didn't use this. So when you call set value, we put values here. When you want this column name, when you want this, all we need to do is give you column to values dot get column name. Now this can also explode. Yeah, if you want a column that is not here, yeah, we should fail. On this one, we can actually fail. Really simple, and this is if column to values doesn't contain column name. This is a good time to explode. So this would be throw new illegal argument column not found in row. It should be in table, but it actually checks it's inside the row, because right now the rows are kind of separate from the table. Each one has their own configuration for columns. So in this thing and column name. Okay. So this is still valid. We still don't have this. But if you try to get, something this, it will actually explode. So let's see if this works, if what we built it works. So let's disable this line and run it again. Look at this. Yeah, it did print. And this will actually get caught. This error should get caught because of the check that we just added. Column does not exist, not found in table. Okay? Yes, so this works. Um, so what will we do next? I think we still deserve columns and cells. And the reason for it is we already see that because of the way we have cells, columns being treated as strings, you will have to do a lot of manual checks to see, hey, does this column exist every time you insert a row. Now we can do this better by using a column object and maybe using cells as objects. We will do this afterwards. Um, yeah, yeah, yeah. It looks solid. Yeah. We obviously we can add, update and delete, but it actually will take us away from the main parts, which is fixing this and making it more robust. Okay, great. So, but this looks like a good start. So next session we'll probably fix this so that you cannot make a mistake with columns. I don't think delete and update are that important now. But yes, we'll do the object so that you cannot make mistakes, because now you can make mistakes. In CQL, you cannot make mistakes. Yeah, it always complains. Um, sure. Um, okay, that's it for now. Let me stop this recording.